I'm Imran.
I'm Ibrahim.
Mustafa. I'm Justin. And we are Future Energy Solutions.
Climate change is a serious issue that affects all of us and has severe consequences such as rising temperatures, shrinking ice sheets, rising ocean levels, and an increase in extreme events such as droughts and heat waves. This can threaten human health, and the changing weather patterns could result in food and water shortages. The CO2 levels are the highest they have been in centuries, and these emissions contribute to climate change. The energy supply sector is responsible for around 31% of total greenhouse gas emissions in the UK. To address this, the UK has adopted carbon budgets aimed at reducing emissions. In light of the Paris Agreement, the country would have to achieve net zero emissions by 2050, requiring a 3% yearly reduction.
Our goal is to supply 5% of the UK's electricity consumption, which is approximately 18 terawatt hours per year. 80% of this will be generated through wind power, and the remaining 20% will be generated by tidal energy. We aim to install a total of 335 combined offshore and tidal turbines. The size of the wind turbines would be 7 megawatts, and they will be 190 meters tall, whereas tidal turbines will be 1.7 megawatts, measuring about 50 meters tall with blades 60 meters in diameter and weighing in at almost 200 tons. The electricity produced by us will be completely replacing the 23.1% of EDF's total production by fossil fuels, therefore reducing EDF's contribution to carbon emission to 0% by 2050. The project is expected to start in 2020 and complete by 2050.
The highest potential for offshore wind in the UK is on the west coast, as the wind speeds are typically higher and more consistent. There is also a high tidal potential in some locations, including Swansea and Scotland. Ilay, Scotland was selected as a location for the project as it is one of the few locations that has a high potential for wind energy and tidal energy, with the average wind and tidal speeds of 11 meters per second and 3.5 meters per second respectively. This is ideal as the high tidal potential can account for the intermittency of the wind. These will be used in the same location, decreasing installation and infrastructure costs as it will be installed at the same time using the same transmission lines. Offshore was chosen over onshore as the wind supply is more reliable, the speed is faster, there are government subsidies available, and less regulations. While onshore wind is a mature and well-developed technology, offshore wind and tidal are both fairly new on the market. Worldwide, there are only 7 operational tidal plants, and none of them is used in conjunction with wind. The operating principles for both of these are fairly easy to understand. Just as the wind spins a wind turbine, the incoming and outgoing tidal streams will spin the tidal turbines. This in turn generates electricity through Faraday's law of induction. There are both advantages and disadvantages to running a combined plant. There are technical difficulties associated with this setup. One of them is finding the optimal configuration for minimum cost of production. We will have an equal number of wind and tidal turbines, which will enable every 2 turbines to share the same connection to the grid. Another issue is optimizing the energy management within the system. When there are both high winds and tides, managing these inputs in the most efficient way becomes a problem. There is no general solution for this, as only the right control methods will be able to deliver efficient management. The advantages are clear in our situation. Wind is unpredictable, and a lack of it can lead to power shortages. In order to combat this, we have chosen to use tidal turbines. Since tides are determined by the motion of the Earth, Moon and Sun, they are always predictable and can help the plant deal with the problem of intermittency. By looking at research into wind variability of supply, we have concluded that our planned tidal capacity will be enough. Another advantage in running a combined plant rather than 2 separate ones is a lower installation cost. As we have previously described, by combining the 2 technologies, we can use the same transmission system for both. Needless to say, this can lower installation costs in comparison to 2 separate plants. It is impossible to estimate how big the cost reduction will be, since there are no other such farms.
We understand that installing and maintaining a combined offshore wind and tidal farm will be expensive. However, our parent company, EDF, is fully committed to our cause and will be supporting us financially. The cost for each wind turbine will be £840,000, while the cost for a tidal turbine will be £1.3 million. We aim to have wind turbines supplying 80% of the energy generated, while the remaining will be supplied by tidal power. Hence, the total installation and maintenance cost for our combined system will be £1.7 billion, which in comparison is cheaper than the Hinkley Point C nuclear power plant, and only £100 million more expensive than a wind-only system. Even though tidal power is relatively new, we expect the cost to have from 40 pence per kilowatt hour to 7 pence per kilowatt hour by the time our system is fully constructed. Hence, our average energy costs are £90 per megawatt hour for wind and £120 per megawatt hour for tidal, with our selling price being £160 per megawatt hour for tidal power and 120 pounds per megawatt hour for wind. By doing so, we are able to match the strike price of wind and tidal in the market. With these prices, we can get a turnover of 1.8 million pounds and a payback time of 3 years per pair of turbines.
Thank you for watching, and we look forward to bringing you the future of energy.